Chapter 26. From Fragility to Flexibility. Fragility in digestion reflects a system that can only operate within a narrow range of conditions. Small changes in input, timing, or state produce disproportionate effects because each phase of the sequence is operating near its limit. Acid output is inconsistent, enzyme release does not match substrate load, bowel flow is poorly timed, and motility lacks coordination. The system compensates rather than processes. Flexibility emerges when these same components are aligned and capable of adjusting to variation without losing function. The difference is not the presence of digestion, but the range over which it can operate without breakdown. The transition from fragility to flexibility begins with restoring consistency in early phase signaling and neural regulation. When the system reliably enters a state that supports digestion, secretory output and motility patterns become predictable. This predictability allows each phase to operate with sufficient capacity relative to incoming substrates. Variability in input no longer immediately disrupts the sequence because the system has margin. It can adjust without collapsing into incomplete processing. Structural preparation is the next layer that expands flexibility. When gastric acid consistently unfolds proteins and alters the physical state of the meal, downstream processes receive substrates that are easier to handle. Bile organizes lipids into dispersed structures that remain accessible across a range of conditions. These preparatory steps reduce resistance within the system, allowing enzymes and transporters to function effectively even as inputs vary. Flexibility increases because the system is not dependent on precise conditions to achieve adequate processing. Timing and coordination determine how well this flexibility is expressed. When gastric emptying, enzyme release, and bile flow are synchronized, the system can handle variations in meal size and composition without losing alignment. Substrates are delivered in a pattern that matches processing capacity, and motility maintains contact between substrates and digestive components. When timing is consistent, the system adapts to changes in input by adjusting output rather than failing. Lipid digestion contributes to flexibility by providing a sustained substrate flow that stabilizes energy availability and signaling. Properly processed fats extend the delivery of energy beyond rapid fluctuations, allowing the system to operate under a wider range of conditions without instability. This stabilizing effect supports both metabolic and digestive flexibility, reducing the sensitivity of the system to short-term variation. Microbial and immune responses also shift as flexibility increases. When digestion is complete and substrates are absorbed efficiently, less material reaches distal regions in a partially processed state. This reduces fermentation and lowers the variability of compounds generated within the intestine. The internal environment becomes more stable, and immune signaling reflects this stability. The system no longer reacts strongly to minor changes because the underlying conditions remain controlled. Flexibility is expressed as tolerance to variation. Different foods, larger meals, or changes in timing no longer produce immediate disruption because the system can process them within its expanded capacity. This does not mean that all inputs are handled equally, but that the range of acceptable inputs has increased. The system adjusts its output to match the input rather than being overwhelmed by it. Moving from fragility to flexibility therefore reflects the restoration and strengthening of the digestive sequence. Neural regulation establishes consistent activation, structural preparation reduces resistance, coordinated timing maintains alignment, and lipid processing stabilizes the system. As these elements integrate, the system gains the ability to operate across a wider range of conditions without losing function, and digestion becomes resilient rather than reactive. Restored resilience. Restored resilience reflects a digestive system that maintains function across changing conditions without losing sequence or efficiency. It is not defined by perfect inputs or rigid control. It is defined by the system's ability to absorb variation while continuing to process, transform, and deliver substrates in a stable manner. When resilience is present, digestion no longer depends on narrow conditions. The sequence holds under different meal sizes, compositions, and timing because each phase has sufficient capacity and coordination to adapt. This stability begins with consistent neural regulation. The system reliably enters a state that supports digestion, allowing blood flow, secretion, and motility to align before and during intake. Because this activation is repeatable, the initial conditions of digestion no longer fluctuate widely from meal to meal. Gastric acid rises to levels that match protein load, pancreatic output aligns with incoming substrates, and bile flow responds proportionally to lipid presence. The sequence starts in the correct state rather than attempting to recover after the fact. Structural preparation becomes dependable as a result. Proteins are consistently unfolded, lipids are dispersed into accessible forms, and the physical matrix of food is reduced in a way that supports downstream processing. This removes a major source of variability because enzymes and transport systems receive substrates that fall within their functional range. The system does not need to compensate for poorly prepared material, and efficiency remains high even as inputs change. Coordination between phases reinforces this resilience. Gastric emptying aligns with intestinal capacity, preventing overload and maintaining a steady flow of substrates into the small intestine. Enzyme release and bile flow match this delivery, allowing breakdown to proceed without accumulation of partially processed material. Motility maintains contact time between substrates and digestive components, ensuring that each phase completes its function before progression. The sequence operates as a continuous chain rather than a series of disconnected steps. Lipid processing provides a stabilizing influence that extends beyond the digestive tract. Properly emulsified and absorbed fats deliver substrates over an extended period, supporting steady energy availability and consistent signaling. This reduces the impact of short-term fluctuations in other substrates and contributes to overall system stability. When lipid digestion is reliable, it anchors the system, allowing other variations to be absorbed without disruption. The internal environment of the intestine reflects this restored order. Reduced accumulation of incomplete substrates limits fermentation and stabilizes the chemical and physical conditions within the lumen. Microbial activity aligns with a consistent substrate supply rather than fluctuating loads, and immune signaling decreases as exposure to irregular or partially processed material declines. The system becomes quieter, not because it is inactive, but because it is operating without excess disturbance. Resilience is ultimately expressed as the ability to maintain output under variation. Meals that differ in composition or size are processed without triggering downstream effects because the sequence remains intact. The system adjusts its activity to match input rather than being constrained by it. This reflects a return to a state where digestion operates according to its structure, with each phase supporting the next and the entire process maintaining stability across changing conditions. Stable digestion across conditions. Stable digestion across conditions reflects a system that maintains sequence, timing, and output despite variation in meal size, composition, and context. The defining feature is not uniform input, but consistent processing. When the digestive sequence is intact, the system adjusts secretion, motility, and transport in proportion to what is consumed. Larger meals trigger greater acid production, increased enzyme release, and stronger bile flow. Smaller meals produce a scaled response. The relationship between input and output remains proportional, and the sequence holds without collapse. This stability begins with reliable neural activation. The system consistently enters a state that supports digestion, allowing blood flow, secretion, and motility to align before intake. Because this activation is repeatable, the starting conditions for digestion do not fluctuate widely. Each meal begins with sufficient capacity already in place, and the system does not need to compensate for delayed or incomplete signaling. This reduces variability at the earliest stage and carries forward through the entire sequence. Structural preparation remains consistent across different inputs. Gastric acid unfolds proteins and reduces the physical resistance of the meal regardless of its composition. Bile disperses lipids into accessible forms, allowing enzymatic activity to proceed without limitation. These preparatory steps ensure that downstream processes receive substrates that fall within their functional range. As a result, enzymes and transport systems operate under stable conditions even when the composition of the meal changes. Coordination between phases maintains alignment as conditions vary. Gastric emptying adjusts to match the readiness of the small intestine, preventing overload and maintaining a controlled flow of substrates. Enzyme release and bile delivery scale with this flow, ensuring that breakdown keeps pace with input. Motility patterns adapt to maintain contact time between substrates and digestive components, allowing each phase to complete its function before progression. This coordination allows the system to handle variation without losing sequence. Lipid processing contributes to stability by providing a sustained substrate flow that reduces reliance on rapidly fluctuating inputs. When fats are consistently emulsified and absorbed, they extend energy delivery over time and support steady signaling. This stabilizes both metabolic and digestive processes, allowing the system to absorb variation in other substrates without disruption. The internal environment remains controlled when processing is complete. Reduced accumulation of partially processed material limits fermentation and stabilizes luminal conditions. Microbial activity reflects a steady substrate supply rather than fluctuating loads, and immune signaling remains proportional to actual conditions. This consistency reduces the likelihood that changes in input will produce exaggerated responses. Stable digestion across conditions therefore reflects a system that has restored its sequence and expanded its capacity. Neural activation, structural preparation, coordinated timing, and efficient transport operate together to convert varying inputs into consistent outputs. The system no longer depends on narrow conditions to function. It adjusts to variation while maintaining alignment, allowing digestion to proceed with reliability across a range of circumstances.